Alright, so our fourth type of reaction is going to be double replacement. Double replacement reactions involve two compounds, AB plus XY. They're going to reorder themselves into AY and XB. So they basically flip-flop. A bonds with Y, B bonds with X. Remember that we have to have a cation, which is positively bonded with an anion, which is negative. I cannot have two cations, I cannot have two anions. So that's going to become extremely important, knowing what those words mean and what they look like in a chemical equation in predicting our products. The other important piece of a double replacement reaction is that they form a precipitate, which means solid. And we use solubility rules, which are on page 6 of our reference tables, to determine whether or not a compound is a solid or a non-solid. So let's practice using those solubility rules before we actually look at writing a chemical equation for a double replacement reaction. So if I look on page 6, I have two columns, soluble versus insoluble. Soluble means that it dissolves. So soluble means that it stays as a liquid. Insoluble means that it reacts and forms a precipitate. So we want one of our two products to be in that insoluble column. Alright, so the way that we read these is we use the anions in each formula. So nitrate, chlorine, sulfate, sulfide, phosphate, hydroxide, and acetate. So when we look at our rules, we need to read based on the anion. So for example, calcium nitrate. I need to find nitrates in either the soluble or insoluble column. Well, the first bullet under soluble says all nitrates, acetates, ammonium, and group 1A salts are soluble. So calcium nitrate would be soluble, which means that it stays as a liquid. It is not our precipitate. FeCl2, iron, chloride. I'm going to find chloride under one of my columns. And I'm going to find chloride in the second bullet under soluble. All chlorides, bromides, and iodides except silver, lead, or mercury. Well, this is iron. Iron's not an exception, so iron chloride is soluble, meaning that it stays as a liquid. It is not our precipitate. Mg2S, magnesium sulfide. Sulfide is going to be listed under the insoluble column. It's the third bullet down. It says all sulfides except group 1, 2, and ammonium. So if I read on my periodic table, where is magnesium? Well, magnesium's in group 2. So magnesium sulfide would actually be soluble because magnesium is a group 2 element. Meaning that if it comes after the exception to one of these rules, it actually shifts it to the other column. Next is magnesium phosphate. Let's find the rule for phosphates. Phosphates are listed under the insoluble column. All carbonates and phosphates except group 1 and ammonium. Well, we already found that magnesium's in group 2, so magnesium phosphate would be insoluble. Magnesium is not an exception to the phosphate rule, meaning that it stays in that column where it's listed under the insoluble. Next is nickel hydroxide. Hydroxides are going to be listed in the second bullet under insoluble. All hydroxides except group 1, strontium, barium, and ammonium are insoluble. While nickel is not listed as an exception, so nickel hydroxide would be insoluble. Both of these insolubles form a precipitate or a solid. Lastly is sodium acetate. So I'm going to look for acetate under one of my two columns. Acetates are listed in the first bullet under soluble. All nitrates, acetates, ammonium, and group 1 salts are soluble. So sodium acetate is a soluble compound, meaning that it stays as a liquid. It cannot be a possible precipitate. So that's our practice with the solubility rules. Now let's practice putting them into actual equations. Silver nitrate plus sodium chloride. Silver nitrate, AgNO3, silver has a +1, nitrate has a -1, plus sodium chloride, Na, +1, Cl, -1. Well, double replacement means that I flip-flop. So silver is going to be my cation, nitrate is my anion, sodium is my cation, chlorine is my anion. So it's kind of like the FOIL method. First, outside, inside, last. Silver is going to bond with chlorine. Well, the only thing left in silver nitrate is nitrate, which means that nitrate must bond with sodium. Now, here's where it gets a little bit tricky because you have to both flip-flop and crisscross charges. So silver has a +1 charge, chlorine has a -1 charge. AgCl plus NaNO3. Again, sodium has a +1 charge, NO3 has a -1 charge. In order for this reaction to run, either silver chloride or sodium nitrate must be insoluble. So if I check my rules, let's start with silver chloride. Chlorides are going to be in the second bullet under soluble, all chlorides, bromides, and iodides except silver, lead, or mercury. Well, that's silver, so that means it's going to flip-flop, making silver chloride my precipitate. We abbreviate precipitate in a chemical reaction by either putting an S in parentheses or a PPT in parentheses. It doesn't matter which one you use, but you have to identify your precipitate. Now, we also need to balance these equations. So I have one silver on my reactant side, one silver on my product side. One nitrate, remember we balance polyatomics together. One nitrate on my reactant side, one nitrate on my product side. One sodium on my reactant side, one sodium on my product side. One chlorine on my reactant side, one chlorine on my product side. So this equation is balanced as is. Alright, lead 2 nitrate plus magnesium fluoride. First step is to write our equation. PbNO3. Now lead has a +2, nitrate has a -1, so when those crisscross, I'm going to end up with Pb parentheses NO3 parentheses 2. Magnesium has a +1 charge. Fluorine has a -1 charge. So when I crisscross those, I'm going to end up with MgF2. When I go in to figure out what's going to bond with what, anions bond with cations. So lead, which is positive, is going to bond with fluorine, which is negative. Magnesium, which is positive, is going to bond with nitrate, which is negative. So when I rewrite this, I have Pb. Now again, remember that lead's charge is 2, fluorine's charge is 1. So PbF2 plus magnesium, whose charge is 2, and nitrate, whose charge is 1, MgNO3 2. I've predicted my products, but remember that the imperative piece of double replacement is to check and make sure I've formed a solid. So I need to figure out if either lead fluoride is my solid or magnesium nitrate is my solid. From my rules, I know that nitrates, all nitrates, are soluble, so it can't be magnesium nitrate. Let's check for lead fluoride. Well, fluorides are the third bullet down in soluble, and the rule says all fluorides except group 2, lead, and iron. Well, this is lead, so lead fluoride must be my solid. Remember, we abbreviate that as parentheses PPT or parentheses solid. Now let's check to see if it's balanced. 1 lead on both sides, 2 nitrates on both sides, 1 magnesium on both sides, and 2 fluorines on both sides. I am balanced. Alright, next up is cobalt chlorate, and calcium acetate. So when I go to write my chemical equation, cobalt is going to have a +2 charge. Chlorate has a -1 charge. Calcium +2 and acetate -1. So cobalt, abbreviation CO, chlorate, ClO3. This 2 from cobalt needs to distribute to all of chlorate, so I'm going to put chlorate in parentheses, plus calcium acetate. Again, the 2 from calcium needs to distribute to all of acetate, so I put a 2 in parentheses there. Now let's go through and figure out what our cations and anions are. Remember, cations are always listed first, anions are always listed second. So when I go in to figure out what's going to bond with what, cobalt is going to bond with acetate, calcium is going to bond with chlorate. So then I can go write my equations. CO plus calcium chlorate. I basically just flip-flop partners. With every double replacement reactions, we have to check our solubility rules. So all acetates, first bullet under soluble, are soluble. So cobalt acetate will be soluble. Next, let's find chlorates. Chlorates actually follow the same rule as chlorides. So all chlorides, bromides, and iodides except silver letter mercury. So calcium is not one of those. So actually both of these reactants, both of these products are soluble. So I would actually just write NR or no reaction. If I do not form a solid, I cannot have a reaction. All right, double replacement has one more piece, and that is net ionic equations, and we will talk about that after we talk about combustion, our last type of chemical reaction.